Hi everybody, welcome to Binary Broom. So I really wanted to bring this article because it solved a problem from me. So I wanted to show you this. It's about Python, Celery, and tasks. Well, in order to start, I have to tell you what is Celery and what does it do. If you don't know, Celery is for managing tasks, like the tasks that we have in our project that needs to be executed uh, periodically or just according to some schedule table. Well, that's what Celery does for us, and it has some monitoring tools, it has some error handling tools, and it helps us a lot in handling periodic tasks. So that's what Celery does. So what is the problem here? Well, in order to describe the problem for you, I just want to show you the whole things that are happening when a task gets created and it goes to Celery and then it gets executed. Well, the general thing that is happening is that the tasks come from our project to a message broker. This message broker is a place where the tasks get queued and they get executed one by one in the clear order. This message broker could be anything like Redis or Rabbitmq, that are two famous message brokers that are used here. And after the tasks arrive in this message broker, the workers come and take tasks. Well, the problem starts from here. In the default settings, when the workers receive the task, they send the acknowledgement to the message broker. This acknowledgement means that I've received the tasks and you can remove the task from your queue because I received it and I'm gonna run it. So the tasks will be removed from the queue, and that's it. The problem is that when something happens in the middle of the task's execution and the worker restarts somehow, the task will be lost because we just removed it from the queue and it is not in the worker anymore. So that's the exact problem. Some tasks need to be executed, but the worker gets restarted and it's like the task never existed before. And yeah, we are going to solve this problem that you may have. And the way we are going to solve this is pretty simple. There is an option here that is called Late that saves us from this problem. The way it works is that we just tell the workers that they need to send this acknowledgement when the tasks are done, not in the middle or at the first that they receive the task. So the workers wait until the task is over and then they will send the acknowledgement to the queue, to the message broker, so that the task gets removed from the queue. If we do this, this is what happens when we have a queue here that the tasks are in it, like the task A, the task B, the task C, and we have a worker here. When the worker receives the task C, it starts running the task C, but the task C is not removed from the queue. So when the worker gets restarted and the task in C is removed from the worker, C is still in the queue. So the time that worker starts to get tasks, the C task will get to the worker and it's gonna be running next. So we didn't lost C, but if the worker have sent that the acknowledgement first, the C was removed from the queue and we didn't have it anymore. And yeah, that's how it works. But there are some considerations here. For example, we cannot set late for every single task the task that we are setting actually true for needs to be idempotent. And what does that mean is that the task should produce the same result, doesn't matter how many times it is executed, so that if it is executed twice, the results will be same and no changes will be applied to our database and to our data. Imagine a task that sends emails to users. This task is not idempotent because if you execute it twice, two emails will be sent, and that's a problem. So we cannot set axlate true for this task, because if the worker gets restarted for any reason, just before sending the acknowledgement but after doing the task, then the task will be given to the worker again, because it was not removed from the queue, and it will be executed again, and we will send two emails to our users. So it is not idempotent, so we cannot use this solution for it. And if I want to give you an example of an idempotent task, I can tell you, like, for example, removing something from the database is idempotent. When you want to remove a user or an ID from the database, when you remove it once, removing it again won't change anything. So it is idempotent, and we can do it for as long as we want, and nothing is changed. So we can use this variable. And let me see, what did I miss here? And yeah, there is also a global variable here that we can set for every single task to have axlate true in the environment that we can set this. But as I said, it is not recommended because not every task is idempotent. Also, there is something to be considered here, which is the message broker, Redis or Rabbitmq. Well, for my own problem that I had, the problem was because of Redis. Redis stores the queues in memory, and when it gets restarted, the tasks are lost, and it is not quite reliable for axlate true. And so I recommend Rabbitmq. There are also some other considerations, for example, the efficiency and the way that they handle this. So in general, it is recommended to use Rabbitmq for these kind of tasks that we need them to be reliable, and we need to make sure that they are executed no matter what. And yes, that's what I wanted to tell you. This is the problem that we are solving. The tasks are now reliable. Now we can make sure that the task that we start, that we schedule, will be executed no matter what. But as I said, you need to make sure that the task is idempotent, and it doesn't make any error or any problem if it gets executed twice or three times. Thanks for watching. Make sure to subscribe if you are interested in more content like this. There are a lot of other useful articles that are coming, and hope you enjoy it. Thank you.